And next we're going to look at permutations. And a permutation of objects is basically an arrangement of them, or an arrangement of some subset of them. So when we use this notation here, PNR, basically we're saying from a group of n objects, say I've got a bag of n objects, I'm going to select R out of them, and this counts how many ways I can do it, including different orderings of the, so even if I had the same selection of objects, but I chose them in a different order, this counts those distinctly. It's given by this formula, and you may or may not be familiar with what that exclamation point means. It's a factorial, and here's basically what it means. It's just the product of all the integers up to n. So for example, 5 factorial is just 1 times 2 times 3 times 4 times 5. And that'll give you 120. By definition, we have to define 0 factorial to equal 1. And in fact, generally, the definition of a factorial starts with 0 factorial equals 1. And you could also observe, and this I think is observable from this first fact here, that n factorial is equal to n times n minus 1 factorial. So these two, rule number 2 and this one right here together will actually give you this rule. But basically we just think of the factorial as multiplying all the numbers, all the integers from 1 up to n. And how we derive this sort of permutation formula, like why that formula with these factorials should give us the number of ways I can select R objects from n, from a group of n objects, including different orderings. Why it should be given by this particular formula, n factorial over n minus r factorial, isn't too hard to consider just by looking at an example. So let's suppose we have 20 people in an organization. We want to select a president, a vice president, a secretary, and treasurer. We want to know how many ways we can select the officers. Well, from what we've already done, we could see this, that being a series of choices, that we're going to use the multiplication counting principle. So let's set ourselves up to do that. So I've got 20 people in an organization, and I'm going to make a choice. Only one of them can be president. So if I choose the president first, that means I've got 20 people to choose from. Now, a person can't serve 2 offices at the same time. So once I've chosen that, I've only got 19 choices left for VP. That leaves us with 18 choices left for the secretary, followed by 17 choices left for the treasurer. And if we multiply all these together, we'll get 116,280. Now, we could also think of this as a permutation, meaning I'm going to select 4 people from that group of 20, and the order matters because the order that I choose them in will determine which office each person serves in. And so that would be considered a different selection under these circumstances. And so I'm going to take a permutation. I've got 20 and I'm selecting 4. And our formula says this should be 20 factorial over 20 minus 4 factorial. So 20 factorial over 16 factorial. Now right now it looks like we're going to be dealing with some huge, huge numbers. But dealing with factorials and fractions is actually really easy because most everything is going to cancel out. This 20 factorial is 20 times 19 times 18 times 17 times 16. Don't worry, I'm not going to go the whole way. 16. And then I know I'm going to include all the factors all the way down to 1. So a little dot, dot, dot. So there's my 20 factorial. Down below, I just have 16 factorial. So 16 times 15 all the way down times 2 times 1. And now, of course, take a look at what we've got here. I've got a lot of the same factors on the top as I do on the bottom. All those factors on the bottom are going to cancel with this group. All your factors on the bottom of a permutation and later on also in a combination will always, always cancel. You'll have nothing left in the denominator. You'll always get a whole number for these. And of course, this leaves us with just 20 times 19 times 18 times 17, which is exactly what we had up there the first time we did it. 116,280.